I'm Corey Hulse. I'm part of Feromone Robotics, and we are a swarm-based robotics team. Our swarm concept, to put it into robotics, we want to use the methods of adaptation, self-learning, and organization to create a group of robots that can respond to any sort of task and environment that's thrown at them in the most efficient manner. And each robot will find the best part that it can do to benefit the group as a whole. We want them to be able to assist and conduct search and rescue operations after natural disasters, using these models as the most efficient way to go about it. Why swarm? Well, we believe that it would be really beneficial for these type of applications because 9/11 was a really big one that a lot of people know of. 1 in 6 casualties were rescue workers, which is a huge rate of fatality for people in these types of jobs. I mean, the mortality rate is really high, and these are trained professionals going in here. Our robots, they're robots instead of people. So if one of them goes down the line of duty, we have a couple hundred, if not thousands more to replace them. Primary role we have them doing right now is keeping the workers informed and in contact with one another. And we have quadcopters that will follow the workers around and actually act as relay signals, because we got a lot of feedback from people in the field saying a really big thing that cuts down on time is that they're out of radio contact a lot. We have quadcopters that can follow you around, and when you do radio signals, relay them. And since they work with each other, they're a swarm. If you're going outside even of their relay range, another robot will come and double the relay range. They'll work as a network, making sure all the workers can keep each other informed. A lot of people wonder, won't these robots get in the way? That's a big fear of a lot of rescue workers. We don't want them to get in the way. We're trying to do this as fast as possible. We don't have time to set them up. We don't have time to lug these heavy robots around. That's not a problem with ours. On the right, you can see some of our robots. For example, the one on top is one of our first ground models, and it's smaller than a piece of paper. On the bottom is another quadcopter that we're using. It's one of our early stages of the ones that follow you around. We didn't design it, but we're currently making our own custom version that's even tinier because we want to get them able to fit inside of your pocket. So when they're loading up on their gear, there's no extra steps. It can integrate as seamlessly as possible. The market opportunity is a global market. Any country that's hit by natural disasters has a reason to have these. There's 33 countries in the world, developed nations, that have budgets reserved for search and rescue operations and branches within their government. Most local law enforcements in all of the cities in those countries have their own local search and rescue branches. And there's a huge private sector. Doing market research in Mesa alone, we learned this. There's numerous search and rescue operations in one city alone. And all of these are looking to cut down on time and do an efficient way to save lives. And we believe that we can help that. $60 million were spent by Australia on just one search for the Malaysia airline. That's one country on one search. And there's dozens of disasters, if not hundreds of disasters every year, and that's just one country on one search. So there's a huge budget opportunity for these. The competitive analysis, if you want to buy drones that you have to manually fly and that can only really take pictures or do videos, it's $300 to $800 for one drone. They don't really have that many autonomous features. The sensor capabilities, there's almost none on most of them, and someone needs to be piloting at all time. Our drones are way cheaper. We're trying to get them to fit in your pocket alone, so you don't need to do any fancy hookups, any fancy controllers or training or anything. They fly autonomously following you around as long as you wear a little chip on like a bracelet or into your coat already. It could be sewn in really easy like that. It'd be nothing. They have a multitude of sensors to tell you all these toxic environments, what kind of conditions you're in. Ground-based robots, they can sell from $150 to $300. They don't work autonomously usually. Some do, but they're independent, they're slow, they're clunky, and they're pretty big and heavy, so they don't really cancel out the risk factor of disturbing structural integrity. And they don't work in swarm-like behavior. Ours do and collectively share information. So when they do work autonomously, they know everything that's going on. The business model, we've spoken with a lot of search and rescue operations, and the feedback has been fantastic. Most of the reviews, when we asked scale 1 to 5, how much will this revolutionize search and rescue for you? It was 5 out of 5, almost every time. They're looking for something like this. They're looking for a revolution like this that can help them save lives and not risk their own lives in the process. Because that's the goal in the end. Is just, cut down on time, cut down on cost, cut down on risk, the whole thing. Our robots are cheaper, far more useful with their range of sensors and autonomous functions, and they're non-invasive into the organization's strategies, so they would integrate right into the operations. and it's scalable on a global level because search and rescue organizations are tightly interconnected because there's joint searches conducted all the time, and sharing new techniques, new technology, it happens all the time between them. The team goes me, I'm the lead programmer and behavioral designer for the search algorithms. There's Miles, our lead electrical engineer, that is designing the whole wiring and sensors and electrical interface between the robots, and Alexander Opstead is our marketing and business operations researcher who talks to a lot of the search and rescue guys and gives us the feedback about that. And our roadmap is right now we're wiring up the quadcopters and testing them, getting them to be self-balancing and avoid any obstacles in the environment. We're getting the tabletop versions of our robots, small than a piece of paper, printed it up and testing their full search and recruitment algorithms right now, trying to perfect that so they adapt as fast as possible to any new environment. We hope in the next 6 months, the quadcopter is fully able to go through any tough environments and to be able to relay those radio signals and have our own design custom ones being printed at that time. And we hope to have a vision system up to be able to recognize survivors immediately on our ground team much faster than other ways. So what we need to improve upon this is to get to the next stage of development to really get these custom designs out there. We want some electrical development equipment like soldering irons, PCB mill boards to be able to more efficiently and have higher quality of the productions of our own custom electrical equipment. To increase our capabilities as a team and round out what we can do, we'd like to have new members join us, having more contacts inside of the search and rescue operations game already, so that we can get a wider view of what we need to do to make them seamlessly integrate would be really fantastic. The return on investment from all of these is that we're going to produce robots that redefine the search and rescue game and completely drastically cut down on the time it takes to rescue people, the risk involved, and the cost for these sorts of events. And it's going to lower the threat that natural disasters face as a society today. Thank you.